Hello everybody, Intro to Organic Chemistry. So how do we name an alkane? Well, to name an alkane, we need to know what an alkane is. And to know what an alkane is, we kind of need to know what carbon is and what carbon does. So carbon is that letter C we see on the periodic table that has the possibility of having 4 bonds. Now most elements have 3, 2, or 1 bond. Carbon's kind of special in that he can have more than normal. And not only that, since it's not super electronegative and not super positive, it's in the middle, so he can make friends with almost everybody, especially hydrogen. So carbon is a very friendly element. And since carbon's so good at bonding with everybody, also has some self-love. So carbon can bond with another carbon, which can bond with another carbon, which can bond with another carbon. And you can end up with these long chains of carbons that are all friends. And if you've done your bonding exercises, then you know that you could have triple or double bonds or even a quadruple bond, but in an alkane, we're only going to have our single bonds. That's really what cane is talking about, single bonds only. So first things first, if we have a chain of carbons all connected and having a great time, we're going to need to know how to name this guy. So we're going to call this a chain because it's like chain links. They're all connected to each other. And if we counted how many we have, 1, 2, 3, 4, 5, 6, then we can find its name. Its name is either going to be methane, if it has 1. Meth is the prefix for 1. Ethane, because 2 is the prefix for 2. And we're going to continue on and on and on. We got all these different prop, bute, we got hex, hept, oct, non, dec, and that's pretty easy for you to Google and look up. But for the purposes of this, we have 1, 2, 3, 4, 5, 6 carbons, which means that the longest chain possible for us to have is 6. We don't even have 7 carbons. And that one's going to be hexane. So this guy is called hexane because we have 6 carbons and they're all linked with single bonds. It's an alkane, hexane. If this had double bonds in it, we would change the name. But since it's only single bonds, we can call it hexane and we can be happy with that. So the thing that gets a little complicated with naming alkanes is, well, what if I had more carbons attached? So what if I had a carbon right here, a carbon right here, a carbon right here, and let's say a carbon right here. Let's just add a bunch of carbons. Well, now it's not so obvious what my name would be. So the question is, could I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons? It's decane? Not quite. That's not really how it works. So the way we name these is we look at the longest chain you can trace without picking up your pencil. So if I were to start here, I could do 1, 2, 3, 4, 5, 6, 7. And to get the other guys, I'd have to pick it up. So 7 is the longest chain here. So we have 7 here. I could start here and say 1, 2, 3, 4, 5, 6. Okay, 7 is still the longest. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, found it. Looks like 8 is my longest chain, and it's right here. 8 is my longest chain of carbons, and so this would have the prefix for whatever 8 is, which in this case it's oct. And it's ane because we have all single bonds and they're all carbons. Okay? So this would be octane. Now, what happens with these two that we didn't end up using? That's kind of awkward. So these guys, we would need to give a separate name because this is our kind of side group. So the main chain is octane, but then we've got a separate little group. And these guys have a slightly different way of naming. So we're still going to use meth, eth, prop, bute, all those, hexane, heptane, all those prefixes, except for the smaller ones, instead of saying ane, we're going to use ol. Okay? So if we have a single little carbon sticking off, that's called methyl. It's a methyl group. And if we have 2 little carbons, we're going to call it an ethyl group. Okay? So in this case, we have 2 carbons left that are sticking off connected to each other. This is called an ethyl group. So we've got the word ethyl. So we've got octane and we've got ethyl. So how the heck are we supposed to name this? Well, first things first, we got to figure out where this chain is. And once we figure that out, we're done. So the question is, which side of our carbon chain is busier? And by busier, I mean which side has more extra bits on it? Well, if I were to count how far it would get, it looks like the extra bits are coming off of this carbon right here. So how many do I have to count to get here from the left? 1, 2, 3, 4. What about from the right? 1, 2, 3, 4, 5. It's closer to the left, so I have to name my carbons from left to right with numbers. So this is my first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one. So now that I have numbered my carbons, I said named, I meant numbered. Now that I've numbered them, I know which carbon my ethyl group is on, don't I? It's on the 4th carbon. So I'm going to write 4-ethyl. Now, bada bing, bada boom, we can actually write our full name now. So I have an ethyl group at carbon 4. So my name is going to be 4-ethyl octane. That's the name of this structure. Rewinding, where did I get octane? Because the longest chain has 8 carbons in it. Oct-ane, because it's all single bonded carbons. Where did I get ethyl? Well, there was a bit hanging off the side that had 2 carbons, which is eth. And we said these small groups end in ol. So methyl group, propyl group, ethyl group, butyl group. This is an ethyl group. And where's the ethyl group? Well, we find it on the 1, 2, 3, 4th carbon, which we decided because the left is busier than the right. So we named our chain of carbons 1 through 8. This is a very short introduction to naming alkanes.